Hello students, a very warm welcome to JEE English by Unacademy, India's leading and largest JEE test preparation platform. And guys, today we are going to get into one of the most interesting part of electrical potential. And you must have come across the ways that have been, like previously that you must have observed in your books, etc. But let me tell you, that is not the most apt way to go about deriving the potential at the center of a non-conducting sphere. So we'll take it up the way it should be, not actually the way it has been manipulated to be. So we need to make some changes to it. And at the end of the day, you can remember that equation will be valid until and unless it's not a non-uniformly distributed, charge distributed sphere. If it's a non-uniformly charged distributed sphere, you cannot go by that method anymore. Okay, we'll understand how to work around such problems and how to finally derive the equation that we need, not the equation but the method actually. Okay, right? There is always a method, not necessarily an equation involved in it, on any formula as such involved in it. You can remember the formulas. Yeah, so let's get into this interesting part of electrostatics and this electric potential lecture. And that being said, students, I'm Murlidharan Gopalakrishnan. I completed my MS in electrical engineering from one of the top ranking American university, and I'm also an IIT and who completed BTech from IIT Guwahati. I have 4+ years of experience preparing students for IIT JEE and other competitive exams, and I filed 25 patent applications in India and abroad, and I have a track record of winning several national level science and tech competitions. And that being said, guys, tomorrow is going to be an Unacademy quiz on electrostatic potential. This would be a great practice for whatever you have learned until now, so do not miss it out. It's going to be a very interesting, quiz session. So make sure you are attending it, and we will, followed by that, we will also have a lecture on electrical potential. We'll do some part of it which hasn't been covered. If there are leftover parts in electric potential and that is being asked in your quiz, don't worry about it. We'll take it up post the lecture. We'll start solving it also post the lecture. So make sure you're attending tomorrow's quiz, guys. It's going to be a grand quiz challenge just on electric potential concept, none other than electric potential. So try attending it, and let me tell you, it's going to be an interesting quiz. So do download an Unacademy learning app, and log in into your quiz. And that being said, guys, the most competitive gamified IIT JEE battle ever is on. And yes, it's already on, and this is going to be the second such battle which is going to happen on 22nd of November. So enroll right away. Yes, do it now, guys, because you want to participate in it and win hundreds and hundreds of Amazon vouchers and Apple products like MacBook Air, iPhone, etc. So there are many reasons to enroll in it. Not only that, it would be a great practice for your JEE preparation, where you will be competing with the cream of the nation. And yes, it's going to be the most competitive and gamified IIT JEE battle ever. Enroll today, guys, with Murli Live code, and that would be an awesome thing for you. So do enroll it, and the next competition would be on 22nd of November. And that being said, students, if you are not yet on our Telegram channel, do get onto our Telegram channel. And if you don't have a Telegram app yet, download it from Google Play Store and App Store, and click on to this link which is available in the description box below. Yes, this link is available in the description box below. Once you click on to this link, you can get on to our Telegram channel. Just add yourself to the Telegram channel. Just subscribe to our Telegram channel. Once you subscribe to a JEE English Telegram channel, you will get before time updates on every single lecture that is happening on JEE English YouTube channel. Not only that, any lecture that our lecturers conduct on Unacademy learning app as well, you will get a notification. And that too, before time notifications. We also keep you posted with doubt clearing sessions, etc. and DPPs. So yes, do get on to our Telegram channel. If you're not yet on it, just click on to this link available in the description box below. And if you already have a Telegram app, and if you're on Telegram app, just type in JEE_English. You'll be able to find us. It is the nation's one of the finest channel where you can learn JEE, because we have IITians and IITians and also head of coaching institutes on this channel. And that being said, students, if you haven't yet covered units, dimensions and measurements yet, this is the time to do so, because if you are especially a dropper and a long-term student or a 2021 aspirant in 12th class, yes, do cover it. I know this is a 2022 topic, or this is typically a topic dealt by 11th class students, 11th class students, this is something must for you because this is the beginning topic, so it's all just in 4 lectures, you can cover it. But droppers and long-term students, this is going to be one of the best lecture for you because we have covered anywhere around 300 plus model problems just on units, dimensions and measurements in 5 to 6 back-to-back sessions. And all you need to do is attend these sessions and you will be prepared for your JEE Mains and JEE Advanced, and it's all free of cost special classes on Unacademy Learning app. Yes guys, it's going to be a free of cost special class, so yes, start attending it right now, right away. It's A to Z of units, dimensions and measurements. And guys, in this 4 sessions of 19th September to 22nd September, you will be learning all the theory along with a lot of model problems that has been or a similar model problems that has been asked in JEE Advanced and JEE Mains. And this could be the easiest thing that you can learn for your JEE Mains and JEE Advanced preparation, and the less time consuming. Think about it, all you need to attend this 5 sessions. These are like 4 sessions. There will be a 5th like model problem session as well, where we have discussed around 50 problems and all. So if you attend just those 5 sessions, you're totally prepared for your units, dimensions and measurements. And think about it, all it takes is like 4 to 5 sessions to score the 2 to 3 questions combined your JEE Mains and JEE Advanced. So this is the kind of preparation that you would get by attending this class. And also it's definitely asked topic, it's the easiest topic, hence you want to grab that easy part of the pie. So start attending it guys. And students, if you haven't downloaded Unacademy Learning app yet, do download it from your Google Play Store and App Store. Just type in Unacademy and you will be able to find the first search result as Unacademy Learning app, the most downloaded learning app or education app across India. And then click on to this install button. And guys, there are thousands of reasons to download Unacademy Learning app, but let me tell you, once you click on that follow button and once you have this Unacademy Learning app, you will be able to get all the live notifications on every class conducted by me. Not only that, you will also be able to attend many such free of cost special classes. And guys, you can attend quizzes like national level quizzes for free of cost just by installing Unacademy Learning app. So yes, not only that guys, also if you want to attend Unacademy Combat, yes, you need to have an Unacademy Learning app. So do download it. There are thousands of reasons to download Unacademy Learning app, and these are going to be the 3 best reasons for you. Free quizzes, free combats where you can win amazing prizes like Amazon vouchers and Apple products. And guys, of course, you can get live notification, and more importantly, you can attend classes from anywhere guys, even the special classes. And that being said, students, if you are looking for a champion's tool and the best thing for your JEE Mains and JEE Advanced preparation, it's going to be Unacademy subscription. Why? We have the best educators across the nation on Unacademy subscription platform who are not just teaching you but taking you through a structured program for you to become a JEE champion in your JEE Mains and JEE Advanced exam. Yes, to become a champion in your JEE Mains and JEE Advanced exam, we have created an extensive and an intensive structured program where you will be undergoing, different kind of sessions, like the best kind of sessions for your JEE preparation. But more importantly guys, it's going to be a structured program, means you will be able to prepare in a very systematic manner. Yes, you get all the free of cost lectures, like quality free of cost lectures on JEE English, but there we have the leverage to discuss different kind of model problems, also in-depth concepts, and more importantly, we will take you through this structured program where every 4th session is going to be a doubt clearing session so that you can maintain the completeness in terms of your concept. And not only that guys, think about it, you will be attending mega quizzes, you will be attending quizzes on every such topic. So in a way you will be completely prepared. It comes with all the national level test series, and you will be more importantly attending daily interactive classes with the best educators across the nation, and you can get your doubts cleared on time from the best educators across the nation. So all you need to do to get this best platform or the tool or the program for a JEE preparation is to click on the left hand top corner extension bar, choose plus, choose IIT JEE as your goal, and then click on this, hit on the subscription button guys. And the other beauty of Unacademy is it's one subscription, unlimited access. So you can access as many programs as you want. You can enroll to as many programs as you want. Yes, do definitely download it. Like, you know, the Unacademy learning app, and purchase the subscription if you can afford it. It's the best thing that you can have for your JEE Mains and JEE Advanced preparation. And guys, this all comes at a cost of 2,100. Only 70 rupees a day is all you have to pay for your Unacademy subscription. And students, not only about daily interactive classes, etc., we have you know, live polls and leaderboards going on every day on Unacademy subscription programs. So you can in a way assess your standing, understand your competency, and understand where you're going wrong. And I will be able to also tell you what is the thing that you're going, like, you know, doing wrong while solving the problem. So in a way, you know what, we are able to notice what is going wrong. In a way, we are able to prepare you for your JEE Mains and JEE Advanced program and make you champion in your JEE Mains and JEE Advanced streams and pursuits. And guys, do not forget to apply Murli Live coupon to get the best discount on your subscription purchase. Yes, apply Murli Live coupon and get the best discount. So don't miss it out, and it all comes at a price of 70 rupees a day. So apply Murli Live coupon to get it at less than 70 rupees a day. Let me correct it again. It's less than 70 rupees a day is all you have to pay for it. And guys, you know what, you can also split your payments into multiple parts using our pay in parts payment feature. This is our in-house Unacademy feature where you can split your payments into multiple parts and you don't have to go through the hassle of paying all the fee at once. And guys, we also have access to no cost EMI, which you can make use of to pay your you know, like your payments into using easy monthly installments, EMIs. And this is a no cost EMI, which means you don't have to bear any interest on your, you know, like split up payments. So yeah, you can split your payments into multiple parts using our in-house pay in parts option, or you can use the other payment option, no cost EMI, to do that as well. And yes, we also have other traditional payment modes like debit card, credit card, UPI, etc. But these are two payment options that takes away the burden of paying all the fee at once. So you may want to think about it once before purchasing your Unacademy subscription. And that being said, students, if you're a long-term or if you're a dropout, a 12-month program is for you. Why it is specifically meant for droppers and long-term students? Because you know what, it typically anyway requires, you know, like a 24-month to prepare for JEE, but you guys are already equipped with the kind of fundamentals that you need for your JEE preparation and JEE like Mains and JEE Advanced preparation. And we have dedicated batches for you where we can take you from there until the place where you can become a champion in your JEE Mains and JEE Advanced exam. I mean, a successful aspirant where you're cracking the exam with successful national level ranks. So that is something that we are focused on. But the thing is, you know what, if you're a long-term and dropper, we have dedicated programs for you. We have 6,000 plus recorded materials, 1,000 plus live programs going on, all at a cost of less than 2,900 at a price of only 2,888 only. Again, guys, it's pretty reasonable, pretty economical for the kind of value that you would get. You will get, you know, educated from the best educators across the nation, successful IIT JEE aspirants who knows what you need to do to be successful in your JEE aspirations. And yes, from the elite, you know, like faculties and from the best institutions. So this is the kind of people that you would be having on an Unacademy subscription platform. And this all comes at the price of less than 2,888 only. Apply Murli Live coupon and avail the best discount on your subscription purchase. So do it. And guys, if you are on Unacademy Plus already, if you already have an Unacademy subscription, enroll to my Optics B2A Basics to Advanced coursework, and where we are going to go from basics until advanced of every single, I mean it, every single, each and every topic in optics. So yes, even if you don't know anything, you can get started. Even if you know things, we will take you until the advanced level on in this program. And guys, it has just been launched. It's a comprehensive program in which we will be covering both ray optics and wave optics. It's a complete program for your JEE preparation. So enroll today. Do not delay it. If you are already on Plus, just enroll and start attending the recorded lectures and also come live so that you can get your doubts cleared. And we have an awesome environment over there, students who are, you know, well equipped with the concepts, and who can think in very different ways. So this is the kind of environment that you would get on Unacademy subscription. So if you are already on Unacademy subscription, you can enroll now. And guys, if you are planning to purchase subscription, start it now, because most of the programs are being launched in mind, or launched in on the Unacademy subscription platform, with this in our mind, that you are going to pursue your Unacademy subscription, JEE Mains and JEE Advanced program, or JEE Mains and JEE Advanced exam in next 2 to 3 months. So enroll now. It has just been launched. Few concepts are covered, but there are many left over. So you can still start attending it. There would be 60 plus lectures, 60 plus concept lectures. So think about it. So that way we'll be discussing anywhere around 100 and 150 concepts just on optics. And guys, more importantly, we will be discussing anywhere around 300 to 600 model problems. Yes. So yes, we also have dedicated programs for droppers and long term. Hence, this can be an ideal program for both droppers and long term, and as well as 2022 aspirants or 11th class students, because it is independent of rest of the topics. And that being said, practice, practice, and practice only makes humans perfect, not necessarily. Today we are going to deal with something where concept is going to make you better than the rest. So alright guys, first of all, let's get started with a very easy question, and then we'll move on to whatever we are here to learn. So these are the typical kind of questions that you can expect in your JEE Advanced and JEE Mains. One is going to be concentric spherical shells, where they would ask you potential on each shell. Okay, but one of the things I typically recommend you to notice it, whether a charge distribution has been given to you or some quantity of charge is given to you. So we have discussed in yesterday's lecture. You can watch them later, like the later part of the video after the quiz. We have discussed something very similar, but today we are going to discuss concentric three rings before we get into the derivation of not just derivation, but a problem, very interesting problem around non-conducting spheres, like electric potential inside non-conducting spheres with uniform and non-uniform charge distribution. How do you really work around them? Should you be going by the ways that has been taught in your books? Maybe not necessarily. Or maybe just if you remember the equation for uniform distribution, that is good enough. Non-uniform, you need to learn a new approach. Alright guys, get started on this problem, and always in your exam notice this thing carefully, whether sigma or some uniform charge distribution is given to you, or non-uniform charge distribution is given to you, or quantitative amount of charge is given to you, like Q2, Q3, Q something like that. So in this case, what is given to you? Like a sigma is given to you. All the three shells have same sigma on them, so they have same uniform charge density on them. Of course, a spherical shell with a lesser radius would be having lesser amount of charge distributed on it, and similarly a spherical shell with a larger radius like 4r would have more charge on it. Now the thing is, what is being asked, there are three concentric shells of radius r, 2r and 4r, and they all have same uniform surface charge density sigma on the outer surface. The ratio of electrostatic potential of the shell with radius r to that of the shell with radius 2r to that of that shell with the radius 4r. They're basically, so let's define it this way. They're basically asking you, let's say this is like shell A, which has potential VA, this is shell B, which has potential VB, and this shell C, which has potential VC. So they're asking you the ratio of VA is to VB is to VC. But you know what, whenever such question is given to you in your exam, the thing to notice it, VA is to VB is to VC, it should be in ascending or descending order. Okay, here I've given you the options such that it's all in ascending order. Even if there is like a descending order and jumbled up order, it is not going to be correct, even if it is sigma. Okay, that means uniform charge density. So notice this thing while doing it in your exam. So anyway, I've given you options such that it's a little bit tougher options for you, like where you cannot eliminate any option, you may have to calculate it. So everything is in like descending order, but it can also be in ascending order in your exam, and you can simply cancel out the ascending order option and move on until and unless it's not a non-uniform surface charge distribution. It's not going to happen, right? It's just shells. So what is the point of having a non-uniform surface surface charge density? So yes, get started on it guys, try it out, and I'll get started on it, and up until then, So first of all, I'm going to define these surfaces and charges on them. Okay, so I'm going to call this sphere as A, this green one as B, and the blue one as C. Charge on this is going to be QA, charge on this is going to be QB, charge on this is going to be QC. And what is QA, guys? QA is going to be sigma into 4 pi r square. Okay, and QB, it's going to be sigma into 4 pi 2r square, isn't it? And QC is going to be sigma into 4 pi 4r square. That is it. Now the question arises, what is going to be the potential on surface A, what is going to be the potential on surface B, and what is going to be the potential on surface C. It's a very simple problem yesterday. We'll do it again, don't worry. You can sort of get a revision from this as well for yesterday's topic, but this is a little different from 3 shells, 3 concentric shells, a little bit of linear math, etc. So I'm going to call this point as let's say like P for now. I need to find the potential on the surface P, and how do on this point at the surface P. Now the thing is, how do we do this question? So one, we would have 3 components added to them. Okay, if I'm going to call this as surface 1, this as surface 2, and this as surface 3, there would be a potential on surface 1, or you can say potential VA. This is sphere A, and potential on it is VA. There would be 3 components. One, due to surface 1 itself, VS1, okay, and then due to this sphere S2, which is going to be VS2, and then there is a potential due to VS3, surface 3, which is going to be VS3. That's it. That's all you need to do. Just add up those potential, and at this point P, which is an inner point for surface 3 and surface 2. For shell 2 and shell 3, it's an inner point. For inner point, how would you write it down? So first of all, on surface 1, due to shell 1, it's quite easy. You're going to directly write it down as K, Q, A, R by divided by R. That is the radius of that shell itself. And then due to surface 2, it's going to be K into QB, which is the charge on the shell B. This shell B, this shell C. So on shell B, the charge divided by the radius of what? No. Just the same potential would exist as if it is on that surface of shell B. And similarly for shell C, we are going to write it down as QC divided by 4R. Right? It's quite a simple math. Just substitute the value of QA, QB and QC, and there you go, you will get the answer, guys. I don't think there's a space. We need to move to the next one. Of course, this is the math that we need to solve. So you understood that point. Let me relabel the surfaces. This is going to be surface 1, this is going to be surface 2, this is going to be surface 3, and here lies the point. Okay, this surface. Okay, you understood that point. We are going to call this as shell A, shell B, and shell C. But I'm going to write down that potential on surface A is going to be like K Q A divided by R plus that of K Q B divided. So if they have given you just surface potential of A is this much, surface potential of B is this much, surface potential of C is this much, and they have suddenly asked you a question in your exam to find out surface potential at A if all these 3 shells have been kept as a concentric shells. In that case, you can just directly add the potential and give out the answer. Okay. So we would have only few more lectures on 2R, right? On this electrostatic potential, and we also have one more important concept left over. But be regular, guys. Be regular. So QA, what it is? 4 pi R square and then divided by r into sigma. Okay, so if you notice everywhere there will be a sigma. So what I'm going to do is, simply before we get started, I'm going to take out the sigma common. Okay, I'll write down for 1 and then I'll take it out as common by erasing it. So QA, what it is, sigma into 4 pi r square, right, divided by r, plus of, you will have k into QB sigma into 4 pi 2r square divided by 2r, and then there would be k into QC, which is going to be 4 pi 4r square, and this should have been also 4r divided by 4r. There should be a sigma. If you notice, k sigma can be taken out as common, and 4r gets cancelled, 2r gets cancelled, r gets cancelled. It's simply, I don't know where do I write it. Let's write it on the next page, or let me write it down over here. Okay, so VA is equal to, I'm just pulling up this equation over here. 4 pi can be taken out as common, sigma can be taken out as common, k can be taken out as common. So 4 pi k into sigma has been taken out as common. Then inside that you would have r plus 2r plus 4r. R plus 2r plus 4r, right? This is nothing but 7r, but I'm going to keep this term as, you know, like term as a constant value. Okay, 4 pi as a constant, 4 pi k sigma as a constant value, and just operate around r, because at the end of the day you'll understand that always do this in your problem. You don't have to, you know, do the entire math like calculating it as 28 pi k sigma r. No, don't do that. That's going to become lengthier. So what you want to do is just add up, keep it as 7r. That's it, 7. Okay, it's a simple problem, guys. It's a very simple problem, right? But you will get a perfect understanding in 3 concentric shells, and post that we can move on to the next concept and problem very easy. And now we need to do for shell B. I hope you have wrote it down. 4 pi k sigma 7r. Okay, you need to actually work it out on your own. I've told you in the beginning of the electrostatics chapter itself, practice and practice and practice only can help you in this one. So now on this surface, let's call this as point P dash. Now we need to find out on this surface, and that would be due to 3 again surfaces. One is going to be sphere A, sphere B, and sphere C. Due to surface 1, there would be one. Due to sphere 2, there would be one, and due to sphere 3, there would be another. So if I'm going to find out the potential at shell B, on the surface of shell B, now you can't do the same thing. Let's say I've given you potential like this, etc. Then try to write down the equation. If it was a smaller shell, you can add all 3 of them. If it's a middle shell, you can't do it at all. Middle shell or outer shell, you need to do the entire math. You'll observe this thing. So there will be like 3 potentials. One is due to surface S1. I'm going to call this time, earlier we called it as S1. So V, this time I'm going to call this as VS1 dash or V dash S1, something like that. And then I'm going to call, due to surface 2, it's actually just VS2 itself. Okay. And due to surface 3, it's going to be VS3 itself. Because S1 dash only has changed. Why S1 dash has changed? For S1, for sphere 1, for the shell 1, sorry, it's not sphere. For shell 1, it is at some distance 2r, at some distance 2r away from its center. Okay, these 2 equations will remain the same. It is as if on the surface S2, yes, for surface S3 it's an inner point. For surface S3 it's an inner point. So it would be the same potential as if, just on the surface S3, just due to the charge on the surface. So one thing would be changing over here. So it's going to be K into QA divided by R or 2R. It's 2R, not R anymore. Okay, rest is going to be the same. KQB by, like 2R, and then we are going to have KQC divided by 4R. Okay, inner point. So same as the surface potential. Just you need to do rest of the math and you will get the answer. And all right, P dash. So shell A, shell B, shell C, surface 1, surface 2, surface 3, and relabeling it, and potential at point B, it's due to 1 is going to be K is common, and QA is how much? 4 pi R square into sigma. Okay, we can take out sigma common, but let's do that later. Divided by 2R, not R anymore. Plus that off. We know from the earlier one, it's basically going to be 4 pi 2R into sigma. And the next one is going to be 4 pi 4R into sigma. Just take out the sigmas as common. Okay, this would be like a larger bracket, I guess. You're understanding? Okay, we'll just turn it into a larger bracket. Alright, now just take out K sigma common and 4 pi K sigma common. I mean 4 pi K sigma common. R square by 2R, it's basically R by 2. Here you have 6R from here, 4 and 2R would be added up. Okay, so basically earlier one we had 4 pi here. If you're noticing, why have I directly written it as 2R? Earlier we used to write it as 4 pi like 2R whole square into sigma divided by 2R square. Sorry, divided by 2R. So that square gets cancelled out and it will only be 2R. Okay. And instead in this case it was like 4 pi in this case it was like 4 pi 4R square by sigma divided by 4R. Instead we are writing it down directly as 4 pi 4R into sigma. Only here it has changed, hence that is the reason we are working on. So that being said, this is going to be R by 2 plus of how much R? 2R plus 4R, 6R. Rest has been taken out as common. That is it, guys. That is it. So try to keep it in terms of 4R, 6R, and so that's going to be like how much? 13. So already you got a hint in your question. If you are going around it, if I would have been you and this would have been an exam, what would I have been doing? I would be trying to notice that in the second ratio point is there a multiple of 13. If there is a multiple of 13, I would right away simply say that okay, that should have been the answer. Okay, let's test it out whether that works. Okay. So first of all, let's write down the answer. 4 pi K sigma. I'm just going to keep 4 pi K sigma intact. All I am going to do is I'm going to change anything around over here. All the three things that we derive. Okay, that way our math becomes very easy, guys. Very easy. Alright, so there should be a multiple of 13. Okay, we have two such equations. So we can just eliminate one. And we can eliminate A and D, but your answer should be between B and C, and okay, multiple of 7 also exists, so we need to do the calculation for the third one to know the answer. Okay, so let's get into the calculation of on the surface. Which one? 3. Shell C. Shell C. Surface 3. Alright, so there would be a surface 2 shell B. Okay, sorry, why am I drawing this point? Irrelevant. B, and this is surface 1. Shell A, shell B, shell C, surface S1, S2, S3. So now I need to calculate at this point, let's give it a name as P double dash. Okay, now I have to calculate on P double dash. So this is what at point P double dash, it is the same as the potential on surface C. And what all would come up? 1 due to the effect of shell S1 at a distance 4R from it. So it's going to be BS1 double dash this time. It is like 4R distance away from the center. And now for S2, it's a point outside that shell at a distance 4R again. So this is going to be 4S2 double dash. And potential on surface S3 is going to remain as it is. Alright, again do the math. It's going to be KQA by 4R this time, and there would be again KQB by 4R this time, not 2R anymore, and this would be KQC by 4R. Now there is a lot of math that we need to do, guys. So this is something that we need to obviously work around. Alright, I am just seeing your messages now. Can you play an academic quiz on PC? Aditya, Sai, Koka. Yeah, I have just noticed your message. I don't know why didn't your messages appear, guys. Didn't understand the surface potential, Papi Reddy. Okay, sir, can I complete physics in 60 days for JEE 2020? Of course, possible. So I'll come to the query one by one. Let me solve this. I've just noticed your question, students. I don't know, for some reason the chat didn't appear. So I'll come to your questions. Okay, let me just complete this point and I'll come to your questions. And do not forget to like this video. Do not forget to subscribe to this channel so that you can get timely notifications on such amazing lectures happening every day. I'll come to your question one by one. Just give me a moment. Let me complete it. For some reason, all this chat didn't appear. Okay, so we see on potential on the surface. See, Papi Reddy, your query will be clear. So once can you again have a look at the video and let me know if you're not understanding it. I'll get to your query. For rest of you both, just give me a moment. I will get to your query, guys. So this is due to surface S double dash. So this is KQA by 2R, I believe that's what it is. I'm going to directly replace the value of QA, by 4R. Let me correct this quickly. And I'm going to also write down the value of QA as it is. So what is QA? It's sigma into 4 pi R square plus of K into QB, which is nothing but sigma 4 pi 2R whole square divided by not 2R but 4R. Then it is K into sigma 4 pi 4R whole square divided by 4R, just like the earlier one, you'd get as 4R. So just add up these values and take out sigma as common. That is all you need to do. So, alright, what is surface potential? That's a good question. Puppy, okay. Attend tomorrow's quiz. I believe that would be more clear. Alright, this is going to be how much? 4 pi K into sigma into R square divided by 4R. It's going to be R by 4. And here it is going to be 2R square divided by 4R. It's going to be 4R square divided by 4R. It's going to be a R. And then here it is going to be just 4R. We have already derived it. Just keep it as it is. Then add it up, you will get something like 5R plus R by 4, which is nothing but 21 by 4. Right? BC is equal to 4 pi K sigma 21 R by 4. Alright, guys, that is it. Now you have derived all the three values. You can take the ratio and move about it. Okay, let me come to the first question. Can we play an academic quiz on PC? I don't think so. Sir, can I complete physics in 60 days? Rocky Balu. Yes, you can complete your physics in 60 days. Aditya, Sai, no, you cannot play an academic quiz on PC. You need an academy learning app. And Rocky Balu, yes, you can do it in 60 days, but you need to move very strategically. Have a look at the strategy video. And Papi, sir, I didn't understand the surface potential. So what is surface potential, guys? Okay, let me come to this point. So I believe there is if there are someone, if there are a few students who didn't understand surface potential concept, try to understand. So surface potential on shell C, or the potential at a point on the shell C, it is going to be the charge on shell C, which is going to be KQ by R. In this case, it's going to be KQC by 4R, right? And then it would not be just be one potential. but also due to one charge, but also due to charge on shell B. In this case, what it is going to be? KQ by R. In this case, it is KQB by 4R. Isn't it? KQB by 4R. Then due to the third shell, that is the innermost shell as well, you will have, a potential on surface C. At a point on surface C, it's going to be KQA by 4R. Potential, it's a scalar quantity. You would add them up. Superposition of potential. That is it. You find potential due to one charge, you find potential due to another charge, add it up. Until unless they are not of opposite signs, unlike charges, they would not get subtracted. Okay, I believe this is clear. So for surface you got it as K sigma by for surface, due to surface A, you have got it as K into sigma 4 pi r square. Instead here I have written it as sigma 4 pi r square. It was uniform charge distribution rather than charge itself. Q1, like Q2, Q3, Q, it has been given as sigma. Okay, let's move on then and start the ratio. I think it's a simple question now. I believe there should not be any confusion anymore. Potential on surface A, surface B, surface C. Surface A, we got it to be like 4 pi K sigma. So I'll tell you the reason why I didn't do the entire math or the complete math and just kept it as it is, because it is easier. This is a constant. You have noticed it. Always you need to do that in your exam. It may feel half complete, but that is how you have to work around it. This was 13R by 2 and that was on a point on the surface of the sphere B, and on C it was 4 pi K sigma. We just derived it, 21R by 4. Take a ratio of all three of them. BA of course must be greater than VB, must be greater than VC, but these all equations were given not in our favor, hence we had to do all the calculations. 7:13 by 2, this all are same. 4 by K sigma, 4 by K sigma, R, these all would get cancelled out, so you would get something like 21 by 4. Multiply all of them by 4, you would get something like 28. Of course the first value should be larger than rest of the values. In this case, if it's a uniform charge distribution or even same kind of charges, Q on the innermost surface, it will be the max. It's like K 2Q, Q 2Q and 4Q. You can think about it. Okay, try to imagine these things. These are very easy. So the answer should be 28:26:21. With this, we can get into the non-conducting sphere part very easily if you understood. Okay, so the answer should have been, I guess, C. Unfortunately, we had to do all the math, and yeah. All right. Now let's come to the most interesting part of this entire electrostatic potential. So it is like asking you, non-conducting sphere of radius r as charge plus q uniformly distributed throughout its volume. The electric potential at the center is 0 because charge enclosed is 0. Does that mean at the center there is no charge enclosed? Think about the center of the sphere. Here there is no charge enclosed. Is it 0? Or electric field is 0? Should be 0, or it should be kq by r, as if it's on the surface. On the surface it's going to be kq by r, or whether it should be like other some values, 2 kq by r and 3 kq by r. Let me tell you, it's not going to be 0. Electric field is of course 0. Why it's not going to be 0? Think about it for a moment. We have done so many model problems around concentric shells, spherical shells, because I wanted you to understand this concept really clearly, isn't it? So I think you can take a moment, think about it, also try to guess the answer. Most of you know the answer because you've already done a very similar one, maybe in a different way, but you want to change this way. All right, so let's get started. First of all, why it would not be 0 at the center? Let's understand that point. Center, we have the center, and I'm going to call this point as C. Now think about it. Okay, this center is very small, not this big as you can see in the picture, but I just highlighted you. So now the thing is, you know what? Now at the center we have like, you know, 0 charge, but there are like shells, right? The sphere is nothing can be taken as multiple shells. Think about it. One shell over here, thickness, then there would be another shell over here of some thickness. So just like what we saw earlier, each shell would be creating some potential, right? There are like many such shells. Okay, there would be many such shells. Even the outer surface is a shell. The shell, this time the shell has some thickness, right? Even the earlier time it had some thickness, we ignored it, and we generally know if it's a conducting case, all the charges would be distributed on the surface. If it's a non-conducting case, it can be distributed like a plastic or something, like it has a dielectric constant, it can be distributed throughout the volume. Okay, so that way we have multiple shells with some charge holding on them. Okay, these are like some thick shells. An example in this case, let's call this to be shell, and let me quickly do a thing. So this is like a shell with some thickness. Okay, throughout the volume it has some thickness. Let's call this thickness to be like dr. Everywhere the shell has a thickness. Shell's thickness is like dr for now. Okay, small dr. Okay. Now let's understand one thing. It's a uniform charge distribution. It's a uniform charge distribution. So if it's a uniform charge distribution, what is the thing that we are concerned about? Spatial charge density. As we did during the electric field, it's the same thing. It's going to be spatial charge density. Spatial charge density is the quantity we are concerned about when we are talking about charge distributed throughout the volume. You understood there are multiple shells, I believe. It's like the same kind of thing, but each shell has some thickness. Okay, and of course you are going to integrate it. Okay, and rho is the spatial charge density, but how do you define rho? There would be charge all throughout the volume, isn't it? Not just over here, throughout the volume. I mean, like throughout the volume, not just around the shell, etc., etc. You would have some. If it's a plus charge, it's plus charge. If it's minus charge, it's going to be minus charge, whatever it is. And yes, for negative charge distribution, on the case where we studied about concentric shells, there you would see that you know what, the potential is least in the innermost shell. Okay, the reason is it's negative, no other reason. Okay, mathematically magnitude wise it's more, but if the negative charge distribution, it's going to be different. All right, that's it. So yeah, it would look something like this throughout its volume. And that being said, we need to find out the value of rho. The spatial charge density distribution. Rho is going to be how much? Q is the total charge. What is the volume of the sphere? What is the volume of the sphere? 4 by 3 d pi r square. Let's keep it like this for now and substitute it at the end. You need to understand every single point. It's a uniform charge distribution. If it was a non-uniform charge distribution, not a uniform charge distribution, the rho's value will be given to you in the exam. Okay, if it's a uniform charge distribution, all you need to do is simply take up a row for each element. Simply take up a row for each element dr. Okay, that means this dr would have row into dr in it. Okay, but of course it's not going to be row into dr. We need to calculate. Rho is for spatial charge density is going to be, we'll understand. Okay, so let's say I'm going to take a small shell at a distance r from the center, and this shell has some thickness, not like a very thin shell. It's a very thin shell, but this very thin shell also has a thickness. This very thin shell also has, isn't it? Yeah. All right, this very thin shell also has some thickness. I'm going to say this thickness is like like dr, just like what we did earlier. We took a small element dx, dr, like dv, something like that. So the small shell's thickness is dr. Okay, this time not dr, but let's keep it as d small r. Okay, because the distance from the center we are going to take it as r, because that's not going to change, but this is how we do it. So now the thing is, you know what, there are two things that you need to think about in this case. What is going to be the charge on this small thin shell at a distance r from the center? First of all, let's understand dq. Generally we would write it as rho spatial charge density into dv, where dv is a volume. In this case, what is dv? It is going to be 4 pi r square dr, surface area into the thickness dr. That's it. Now, next question arises. Second thing would be, what is the potential due to this guy at the center? Right? We're talking about center. You need to calculate the potential at the center. So due to this elemental thickness, there would be a potential which is going to be k dq by smaller or larger. Smaller, right? By larger. This guy is at a distance r, and is radius is also r, hence it should be smaller. So this is going to be how much? K into rho into, I'm not substituting the value of rho, but do understand in this case rho is constant, into dr divided by r, right? So r would get cancelled out, so we'll get dv to be something like 4 pi k into rho into just taking out 4 pi k as common, and rho is also constant, so I'm just keeping r dr separately. We'll carry forward this equation. Okay, now I need to integrate it not just for this one shell, I need to not calculate it for just one shell, but I need to add up due to multiple such shells. If I'm talking about another shell over here at a distance, let's say r dash, potential at the center is going to be, okay, let's say this radius is r dash, the potential at the center is going to be like due to radius r, due to r dash, and so on. Many such will be there. So basically you need to integrate it from 0 until capital R. You need to integrate it from 0 up until capital R. That's it. Right? It's inner surface for each of this shell. It's an inner surface for each of this shell. That's it. Isn't it? It's simple math. No more complication is involved. So but you need to integrate from 0 to r, that's it. Each small shell around this place will be creating a potential. All right, let's move on to the mathematical part then, that is going to be integration. So potential is going to be integration of dv, and substituting the value of dv is going to be from how much? 0 to r, and what is dv we found out to be 4 pi k into rho into r dr, r square dr, r dr. Okay, I hope you got the point why it is r dr. It's not like r square by capital R, because each shell is at a distance r from the center. It does not matter, it's going to surface potential. Each shell only has a radius, hence we wrote it as small r, not capital. Okay, all right, that being said, like each is like a shell with a radius r, right, and spanning from 0 to r. That being said, take out this constant terms out, 4 pi k into rho, and integrate this r dr. You would get out, you'll get it to be like something like 4 pi k into rho into r square by 2. And this would be spanning from 0 to r. And calculate this. What is the net potential? Net potential, right, or potential at center. There was dv, dv, dv. We added up all such dv's. So this is going to be full potential now. R square minus 0. Just keep it as r square by 2. It will be minus 0. Now substitute the value of rho to get it in terms of q. This should be your expression. Now just substitute it in terms of q, rho in terms of q, you'll get the answer. Okay, let's do that thing as well. So we got vc, I'm just carrying forward the same equation, 4 pi k into rho into r square by how much? 2. Okay, rho, I'm just going to write it down in a different color. But we got this is the constant value over here. Okay, now just let's write down, let's substitute the value of rho. What was rho? Rho was how much? Q by 4 by 3. Okay, there is a q by divided by 4 by 3 pi r square, isn't it? That's what r was. There was a q divided by volume of sphere. This charge plus q is uniformly distributed throughout the volume. Now just substitute the value of rho, guys. That's all you need to do. You substitute the value of rho, it will be q r. Okay, let's do it. Vc is equal to 4 pi into k into q divided by 4 by 3 pi r cube. Let's say square, then correct me, it was cube. Okay, into r square. R square, r cube, 1 r would be remaining in the denominator. Pi gets cancelled out, and 4 gets cancelled out. What are you getting finally? 3k cube by, there would be a 2 as well, I guess. Okay, so you'll be getting a 3k cube by 2r. That's it. All right, that's all you need to know how to do this question. Now if I give you like non-uniform charge distribution, you need to find the potential at the center, you would still be able to do it. So yes, it's going to be 3k cube by 2r. It should be greater than k cube by r. That way we could have understood it, because on the surface it is going to be k cube by r. So try to understand it from this point. If it on the surface it was like it's going to be k cube by r, if it was like conducting sphere, etc. Now in this case it should be greater than k cube by r. Right, on the surface it's going to be the least, on the center it's going to be the maximum. Hence, in this given option, this thing is k cube by r. Of course, it has to be greater than this, and this 2k cube by r. This is lesser than 3k cube by r, or sorry, k cube by r itself. Hence, you can cancel out this. You can cancel out this. It's not 0. We know that there are like multiple concentric such shells, and we have calculated 3k cube by r. Alright, now let's come to a case where you have a non-conducting sphere of radius r, and this time it has a spatial, it's not special but rather spatial. So spatial charge density of rho distributed throughout its volume. This time is the non-conducting sphere again, but now what has happened is you need to find out the potential at the center, and this rho is varying with a radial distance. Okay, let me read the question. A non-conducting sphere of radius r has a spatial charge distribution of rho distributed throughout its volume, and rho varies with radial distance inside the sphere as a radial function of r, given as rho is equal to a into r, where a is a constant and r is the radial distance from the center. That means the charge density is varying with every r. So now you need to find out the electric potential at the center of the sphere. How much? Take dielectric constant to be approximately 1. Okay. If dielectric constant was present, you would be dividing it with the dielectric. All right, try doing it. Maybe you want to get started along with me, because if you try doing it, it may not take much time. You can do it quickly if you understood the concept. Draw that shell. You'll be doing it again. You'll be drawing that shell, but this time it's going to be a non-uniform charge distribution throughout the volume. Think about it. Outside shell would have the maximum potential. Inside, like shell would be having. Sorry, not the maximum potential, but the maximum charge. I'm really very sorry. Maximum charge, and the inside, shell would be having minimum, like lesser charge, right? This is the way to go about it, guys. This is the correct way, right? All right. Now, as usual, you need to draw a shell. Let me draw the shell. So we are going to draw a shell at a distance r, and we are going to say this guy has a thickness dr. Okay, throughout its surface. You can start solving it, guys. You can start solving it along with me. By the way, you have a hint what should be the answer. What should be in the denominator. Number is the key in this game, like just in this particular question. Number is the game. Okay, dr thickness, r radial distance. We know this time charge density is also changing. We can't anymore say that going to be like rho into 4 pi square dr. We are going to say that, but this time rho is different. We are going to say rho is equal to a into r. All right. So what is the charge on this guy? Let's say it's some dq. This dq is changing with distance r. Do remember that. So dq is going to be rho into dv, volume, dv, not potential. So let me give this something like d small v, because potential also has v. Okay, I'm going to give this a small v. So sorry, this is not q rho r cube dr. Okay, probably you understood the answer to some extent, what should be in the denominator, etc. And this is the way to go about it. Need to integrate it like by k cube by r. All right, but anyway, let's do the math now. So we need to find out the potential dV, which is going to be K into dq by R, right? K into dq by R. Okay, let me correct it. I'll write down on the next page. Okay. We have a shell at a distance r from the center as dr. These things are clear to us. Now what we had was like dq value. dq value we got out to be like something like 4 pi k into k is Coulomb's constant into a into r cube dr. And we wanted to write the potential was k into dq by small r, distance small r from the center. That does not matter because it's going to be this. So this is going to be k into I don't know why did I write to be k into r. Why did we write it to be like, sorry, so this should be 4 pi k into a into r cube divided by r into dr. Almost you arrived at the answer. Why? In a way, from the given options you can guess the answer. dv is how much? K into k is also going to be a constant. It's just a Coulomb's constant. So I'm going to keep it as a constant inside. Just a moment, guys. I think I wrote something wrong over here. That is k. Again, there will be a k. So this should be 4 pi k into a. This will become r square dr. From here, you already know what should be the answer. You should be integrating from 0 to r. On the denominator, you should have something like 3 or something. Like put down the value, put the value of a 1 by 4 pi epsilon naught. Alright, let's integrate it, and we have to integrate it from 0 up until r. Okay, so yes, the potential total at the center is going to be integration of dv, which has to span from 0 to, so this would be like r cube by 3. So 4 pi k a r cube by 3. 3 should be coming in the denominator, and r to 0. So yes, now you do the math, you will find it out to be Vc, that is potential at the center, is equal to 4 pi. Well, let's say even if it's a uniform or non-uniform charge distribution, what if I had to find it out at some point, inside the sphere? How do I do it? Okay, how do we do that point of this derivation or calculation, etc.? I told you it's an interesting part, so don't worry about it. It's going to be very interesting. Okay, and let's move on and get started on this. So what has given us now a non-conducting sphere. Luckily, we have plus q uniformly distributed throughout its volume. Now we need to find out the electrostatic potential at its center. Okay, at center, and to that of a distance r by 2 from its center. Okay, the distance r by 2 from its center. Now the thing is, you are at a point over here. Right? Now this is like, let's say this r by 2. Center we already did it, so it was like 3 k cube by r. You remember that? Now the thing is, now I need to do it over here. how do we do this? Try it out. You need to maybe get started on your own and think about it a little bit. Then I'll get started. First of all, we are going to the standard thing. Okay, I'll get started then. So at center to that of at the distance r by 2 from the center. That is what you need to find out. And of course, answer B cannot be true. That because it is 3:4. The center is 3. Calculate it and see. Okay. First of all, I'm not going to talk about Q, but rather rho, charge uniformly distributed across its volume. That is going to be spatial charge density. Spatial charge density or volumetric charge density rho, which is going to be like a constant value in this case because it's uniformly distributed. Q charge is uniformly distributed throughout its volume. So that's going to be 4 by 3 pi r cube, which is nothing but charge by volume. Let's keep this value as it is. Get started on the rest of the answer. Alright. So now the thing is, I am at a distance r by 2 from the center. Now comes the most interesting. Okay, now comes the most interesting part of our discussion. So it's at a distance. A moment. R by 2 from the center. Okay. R by 2 from the center. Need to draw a sphere and yes. This is what R by 2 from the center looks like. You need to find out potential at a point r by 2 from the center. Now at a point by 2 from the center, there is a thing, guys. What's the thing? Unlike the rest of the cases, there is a catch. What is a catch? Think about it carefully. Two kind of things are influencing it. One would be from here, from the center to the surface, there is a solid sphere of radius r by 2. Right? From center to the surface or at the point r by 2 from the center, there is going to be a sphere r by 2. That is going to have a potential due to the inside of that point or due to the inside points of due to the inside charges around that point, there is going to be a potential. And then due to the shells that exist outside. So if you are noticing, not just that inner solid sphere, but there are multiple shells that exist outside. So then there are going to be two potentials that you need to add. Isn't it? Two potentials. Of course, you are going to integrate it for the outer shell. One is the outer shell. Outer shell, I should say, or shells. So there are multiple shells. And the other one is due to the inner sphere. Due to the inner solid sphere. So two kinds of potential exist. So if I had to find the potential at a distance r by 2 for this case, I would be doing a thing. I would be finding two potentials. One would be due to outer shells. Okay, let's call it as something like V outer. And then the other one would be due to the inner shells. Or the inner sphere, sorry. V inner. V inner is easy, isn't it? V inner is basically KQ by r by 2. That q is going to be q inner. Okay, so we need to first of all find out how much of the charge is present in this like inner shell, and we need to calculate it. Okay, q outer you are not going to do that. Q outer you are going to integrate it from r by 2 to r. Okay, and then add up both these potentials. These both potentials would add up, right? These both potentials would add up. All right. So first of all, we need to calculate V inner. We'll find out V outer. We'll add them up. First of all, let's find out V inner. V inner, according to me, is rather easier. So we'll get started with it as the first. It'll act as if all the charges are concentrated at center and it's at a distance r by 2, or it's as if the surface potential of that sphere with charge r by 2 on it. And what is the spatial charge density rho, which is a constant value in this case. And yeah, that's it. I guess we do have to think about anything, nothing else. So it's basically yeah, let's define the charge inside that sphere is going to be qi. On this point, due to 1, it's going to be inner sphere. We're going to calculate it due to inner sphere, potential due to inner sphere, which is going to be k into qi divided by r by 2, radial distance r by 2. What is the charge qi? It's basically rho into 4 by 3 pi r by 2 whole cube. R by 2 whole cube. R by 2 on the denominator. So this would become a square. Okay. That is it, guys. That is it. Don't have to think very hard. Now just keep it as rho 4 pi etc. just like that, and carry forward this value. And I would rather keep r by 2 whole square separately and see if something can be done at the end. If not, we will have to ultimately merge. All right, guys. So yes, I'm going to write down the final value of the potential over here due to this charge qi, which is basically due to inner sphere at a distance r by 2 from here, at which is going to be vi is equal to we add something like k into did we write down the value of rho? No, k into, so I'm going to write it down as 4 pi k rho. Okay, same value, I'm writing it down, nothing else, I'm doing nothing more. And 4 pi k into capital K into rho into we add something like 4 pi by 3 would also be there, by 3 would also be there, r by 2 whole square. Okay, 4 by 3 pi rho k into rho into r square, r by 2 whole square. You need to do it once yourself so that you understand it better. But yeah, this is a simpler one, guys. Really simple. Let's move on to the outer shell, which is like the interesting part of the entire thing. I think the concept in itself is very interesting. There will be 2 kinds of potential. You need to add them, which makes it far more interesting. And you think, isn't it? All right, guys. So now what we need to do is a little different game. Now what I'm going to do is I'm going to choose first of all, let me draw the surface anyway. Okay, this is at an r by 2 distance. Now thing is the different color. We have a shell at some point, r from the center, this guy would have some thickness, like dr, just like how we did it earlier. Okay, I would have some thickness and this. would be some dr. Now the thing is, what would be the potential at r by 2 due to this guy? What it would be, right? So we are going to calculate V outer. You understood that point. Okay, we need to calculate V outer. First of all, let's think due to this spherical shell at distance r from the center with the thickness dr, what is going to be the potential at r by 2? I'm going to say this is dV. It's going to be k into dq into, is it going to be r by 2? No, it's just going to be r. Okay, so it's going to be k into dq is how much? Rho into the volume. Okay, let's give it a name like small dv, makes more sense. So like a small unit volume. How much is that going to be? K into rho into 4 pi r square surface area into dr divided by r square gets cancelled out. So dv is going to be k into rho into, so okay, for now let's write it down like this, so 4 pi into r dr. Now comes the question, what were we supposed to find out? Supposed to find out something known as P due to this outer shells. Right, how much is that going to be? It's integration of dv from which distance to which distance? R by 2 to r. R by 2 to r. Okay, let's do a thing. While deriving this, I'm going to parallelly derive it from a to r, at a distance a to r. If it was not r by 2, how do we do this? We need to have a value. Right, similarly there we can substitute it to be like, a, etc. Okay, we'll do it at the end then. For now, let's just derive it for r by 2 and let's derive it because I don't want you to get confused. Yeah, I'll directly write down the expression by adding v in, v out. Maybe we'll do it in a couple of seconds. It's not a big deal. Once we get this expression right, it's not at all a big deal. So this should be how much? The moment, so I'm going to correct it out a little bit. So this should be 4 pi into k into rho into r dr. So this would be 4 pi into k into rho into integration of r by 2 r dr. Right? Just integrate it, it's going to be r square. Alright. So integrated v outside is equal to integrated of, let's take out the common values, the constant values outside. So that would be 4 pi k into rho into r dr we had, which is going to be r square by 2, which needs to go from how much to how much? R by 2. That is going to be like, is this all correct? Yeah. So 4 pi k into rho into r square minus of r by 2 whole square. That is going to come out as something like r square minus r by 2 whole square. I'm taking out 2 as common, and there we go. Think about easier way of doing it. So 4 pi k into rho divided by 2 into r square minus r by 2 whole square. It's going to yield what? 3 by 4 r square. R by 2 whole square is going to be r square by 4. So it's basically r square minus r square by 4. Right, this is V out. You derive V inner as well. So now potential at r by 2 is due to two things. Potential at a distance r by 2 is due to two things. Any such point you do this thing. This is the way to go about it. I'm going to give you an expression. That doesn't mean you have to make use of the expression all the time. You can rather, like depending upon the question. Depending upon the question, you'll be doing it. Okay. Now, yeah, the point. Okay. So now at r by 2 distance, I'm going to add up two things, which is going to be V inner plus that of V outer, and V outer we just found out the value to be something like I think 4 pi k rho divided by 2 into 3 by 4 r square. And that was what k q divided by q inner divided by r by 2. That would have been something, I guess, like that would be like 4 by 3, 4 pi by 3 into k into rho into r by 2 whole square. Okay. 4 by 3 r by 2 into doubt we can verify it positive. Okay, here 4 by 3 pi 4 pi by 3 into k into rho into r by 2. Okay, we're just going to add it up. It's the same value, I'm just carrying it forward. So post this, you will get something like 4 pi k into rho. These are all common terms. What is left over here is r square divided by 4, 2 square is 4 into 3, that's going to be 12, plus that of 3 by 4 r square would just remain like that. And 3 by 4, it's 12 is going to be the common LCM, the common denominator, and then you would get it as something like r square by 12 plus of 9 r square by 12, so it would be 10 r square by 12. Okay, r square by 12 plus 3 by 4 r square is going to be 10 r square by 12, because this 3 you have to multiply it with 3 so that you get a 12 on the denominator. It's going to be 9 plus 1 10, so it's going to be 12 r square. Okay, 10 r square by 12. That's it. And there we go. We have this expression. From here we can just simply substitute 4 pi k. What was rho? We wrote it in the beginning as 4 by 3 pi capital R cube, isn't it? Capital R cube. That is it. Into 10 r square by 12. Just do remaining math. Just cancel out 4 pi, 4 pi. You have something like 3 left over here. This would go out as 4, and over here 4 would get something like 5 over here, and 2 on the denominator. So it's basically 5k cube by 2. At a distance r by 2, we did 2 spheres. We chiefly did this because we had to understand those 2 spheres. So due to 2 spheres at a distance r by 2 from the center, is due to both of them, which is going to be like V inner and V outer. Just writing it down again, we got it to be 5k cube by 2. Right? That's the only leftover thing. Oh, okay. 5k cube by 2r. I'm sorry. R is also left over, right? R cube. Okay. At the center, we already derived it. It is 3k cube by 2r. Ratio at that of center on to that, I think to center is being asked. Center to that of r by 2 is going to be how much? 3:5. Just a moment, it should not be 3:5, right? 4, 3, 9, 10 by 12, 4 by 3 pi r, and 10, 12, 12 are in the denominator. 4 by 3 pi r cube get cancelled out r denominator. So you got it, r by 2 to be greater than the center. That's cool. Potentials do add up. Just a moment, guys. Let me verify the thing, whether we did the math correct. 4 by 3 pi r cube k rho divided by r square by 2 is nothing but k into q inner by r by 2, and k into q inner was nothing but rho into 4 by 3 pi r by 2 whole cube. So this is mean. And here we got it to be like 4 pi k rho divided by 2 3 by 4 hours. Nothing but yeah, when is this 2? Thought something was missing, that was 2, hence this would be 8. As this 2 in this calculation would be 8, and this would be like 24. Yes, denominator would be 24, and on the numerator you will not have 10, rather you will have 2 plus of that of 2 plus that of 3, and that would be like 5. Okay, so instead of you'll have something like 24, you will have 2 plus of that of not 5 but rather again. So 9, 2 plus of that of 9, I guess. Is it 2 plus into 3, 9, 11 r square by 24. Okay, so we have a 24 over here. We need to do this calculation a little bit again. At this point, so this would be like we substitute the value of rho. That's all we did over here. R square 24, and then r square, yeah, of course 1 r will be there, and the denominator 4 pi, 4 pi gets cancelled out, 3 to generate an 8, so it should be 11 cube by 11, not 5 but 11 by 8, 11 by 8, right? 11 by 8. This needs to be corrected, please do this. So by 8, 4 pi 12, that is correct, 12, and by 8, that is correct. R square taken out as common, then you will have 1 by 12 plus that by 8, n plus 2, 11, 11 divided by 24. The 3 to generate an 8 by 8. Okay. 11 by 8, at the center we have it to be like 3kq, 3kq by 2r, which we can correct it out to be like 3 by 2 is to 11 by 8, which would give us something like 12 is to 11. Okay, small correction, please to correct it. I will finally keep equation, and it should be 7 by 9 or 12 by 12 is to 1. Of course, it has to be 12. All right. All right, before we proceed into this, let me quickly give out some equations that would be useful. So, white screen. Now, you know one thing, at any point inside, you need to add two things for solid. Let's say you have a solid non-conducting sphere with uniform charge distribution, like Q etc on it. And in that case, you need to find out the potential at some point R inside the sphere. You need to add two things. One is going to be due to inner, and one is going to be due to the outer. And from this, we will get two things. Due to inner, it's always going to be like K into Q inner by R. Okay. K into Q inner by R, which is nothing but K into rho divided by rho into 4 by 3 pi R cube divided by R. So you will get something like 4 by 3 pi R cube divided by R. So it's going to be 4 by 3 pi R square. And due to K outer, you would have something like, you will get 4 pi K rho. So you would get 4 pi K rho, and there would be like a 4 pi R square dr. So that would be like, 4 pi has been taken out. So R square dr divided by R. So that would be just be like R dr integration. You would get something like R square. Okay, so further writing it down, this would come out to be like K into rho into 4 pi. Just these things are being taken out as common, or else let's write it in our way. I hope you understood this point. How did we get it? It's basically K into Q by R, and there we would have R dr left over, so that would come out to be R square by 2. And small correction, guys, this is not just R square by 2. So this should be capital R square minus R. Capital R square minus R square by 2. So just write down further this equation. So here you would get something like 4 pi K into rho into 4 pi K into rho into then we would have something like R square divided by 3 plus that of R square minus R square divided by that of 2. Okay. I think rest is fine. 4 pi K rho, 4 pi K rho R. That is it. Okay, that is all you would have. We got an R square, that capital R square, because we integrated from R to capital R, right? So now if you further write down this equation and substitute the value of Q, it would be Q by 4 by 3 pi R cube. So just substitute that value. So let's say I've substituted the value of Q, rho, in terms of Q. It's going to be Q by 4 by 3 pi R cube, right? So that is going to yield something like 4 by 3 pi R cube. 4 by 3 pi would be get cancelling out, 3 would be remaining, and you would be getting like KQ3. So this would be like KQ, and if I take those 3 inside, okay, what did I do is actually I did nothing. Let me write it down. So you would get something like what did I do is K into 4 pi, I wrote it down as Q by 4 by 3 pi R cube. Okay, 4 pi getting cancelled out, and then we'll carry forward this 3 on the numerator, which I'll take it inside. Let me do this thing, okay. So this would be like k into 4 pi into rho is written as q divided by 4 by 3 pi capital R cube, right? 4 pi would get cancelled out, 3 would be carried on the numerator, and R cube would remain on the denominator, of course, and here plus divided by 3, and this R square minus R square divided by 2. Okay, so you take this 3, you would get you would see something like this, k cube. And if I am going to simplify everything, okay, if I'm going to do something like, you know, simplifying everything in one go, I would rather keep R cube outside and write it down as R square minus of 3R square. So this would look okay, let me write it down. This would be like R square minus of plus of 3R square minus of 3R square by 2, which is nothing but, you know what, 1.5. 1.5 minus 1 is going to be 0.5. So this can be written as that. 3 capital R square minus small r square divided by 2. You have seen this expression before and haven't understood how this came or had a confusion around this. This is the way to go about it. Okay, this is how the potential is varying inside. Okay, so let's do a thing. Keeping this in mind, we'll draw the graph. Okay, we need to draw the graph. Okay, graphing based questions are very popular around non-conducting like, you know, a solid sphere where you have some uniform, non-uniform charge distribution. Derive the equation, understand, do it. Uniform, will do it. You can note it down, guys. So this is correct. All right. So now we need to one axis, of course, our potential axis. This is distance axis. One axis is going to be our potential axis. The other one is going to be a distance axis. Okay. So let's do a thing. Both let's say center is the origin, center is the origin. Now we are going to do it for, as usual, for positive charge. For positive charge, what is the maximum potential? Maximum potential is at the center. This is going to be, for uniform charge distribution, is going to be 3kq by 2r. Okay. Are you getting correct value? You can verify it. Just substitute r is equal to 0. You'll be getting 3kq by 2r. And similarly, substitute r is equal to r, capital R, you'll get it as kq by r. So up until that point, from the center, it will keep decreasing like a square value, and on the surface, that is at r is equal to r, it will look something like. And then post that, it is basically nothing but like, you know, distance from point charge, etc. Okay. Similarly, you will have it on this side, mirror image. Suddenly the graph would change. There would be a shift in the slope. It would of course decrease from the center. Okay. And now this is for what? Positive charge. What about negative charge? Negative charge, the scenario is going to be different in a sense, going to be a mirror image, etc., etc. But as you approach the center, it's going to be minimum. What is that minimum value? Minus 3kq by 2r. It's just the inversion of the value. Okay, that's it, guys. That's it. Same thing. So this is going to be the negative charge. The graph has been inverted. It's a mirror image across x-axis. This x-axis is a mirror image across x-axis, but this is actually right distance from center. Right? Simple. Hello Vaishnavi. Hi Cheswara. Hi everyone. So that is it, guys. That is it. So do practice this chapter again. So what's your question, Vaishnavi? You're new, so yeah, this is the place to get started. Don't worry. You need to start with electrostatics, Vaishnavi. Try to complete all the lectures of electrostatics. So what you can do is, Vaishnavi, I believe you are like a 2021 or 2022 aspirant. I don't know which kind of aspirant you are. So if you can inform me about it, it would be great. If you are 2022, as we can start attending daily lectures so that you can get your doubts cleared, Vaishnavi. And as far as your preparation is concerned, if you're new, guys, what you can do is get started with this and parallelly try to attend the A to Z series happening on Unacademy Learning App on electrostatics, capacitors. So both of these topics can go hand in hand, and that way you're just attending lectures throughout the week, but you're preparing for two topics. And similarly, there are current and electricity A to Z lectures on Unacademy Learning App, that rather than that start with YouTube and then go for it. So that way you will almost have covered 33%, 30% of your weightage in terms of syllabus. Okay, so that is something that you can do. You can attend the 3 lectures on projectile motion, and it would be literally, you would have scored anywhere around 6 to 7 questions in less than 2 to 3. And if you're on plus, start attending optics, 10 questions. So beyond that, we need to cover more syllabus, and it will be nuclear next. So yes, 20 aspirant, 22 aspirant. I didn't get it. Yeah, Chesura. So guys who are new, come every day to the lecture so that you understand things. At least I try to keep it as a very independent topic of others. But if you feel that you are lagging behind, what you can do is you can start covering for electrostatic potential. The shortcut is you can go home today. I mean, like after this class, what you can do is you can cover all the lectures around electrostatic potential, and that way you can start attending daily lectures and you'll have understanding of things. And as far as your rest of the syllabus is concerned, start with the first lecture around electrostatics. You would have to anywhere cover around 12 lectures, and you would have to do that. There is no other way out of it. And as well as start running capacitor lectures on Unacademy Learning App. These are all also available as recorded session. So yes, Cheswara, there is Vaishnavi and Cheswara, there is a streaming from Tuesday to Friday. Generally classes happen from Tuesday to Friday at the what time? 7:30 p.m. It continues until generally till 9:30. Okay. Yeah, daily streaming happens. And this is from Tuesday to Friday, 7:30 p.m. We have so far covered electrostatics. We are almost about to complete it. There are a few more topics. By the end of next week, we will be almost thorough with it. We will start with a lot of PYQs. So before that, try to complete the lecture series. For current and electricity, you can attend it over here as a recorded session. We also have sessions on capacitors. If you're not comfortable attending it on YouTube, you can attend it from Unacademy Learning App, because we have discussed very different kind of concepts to easily solve the problems. So this way you are 75%, 70% through with current and electricity and electrostatics and capacitors, which is going to be like around 5 to 6 questions in your JEE Mains. And post that, you can start attending classes on something like optics. If you're already on plus, you'll get another 2 questions and cover projectile motion, relative motion that has been taught. And do not forget units, dimensions. So near about 8 to 9 questions. And once we begin with nuclear, you will be through with 11 to 12 questions. So 50% of the paper is something. This is the way to go about it, guys. Yes, every day from Tuesday to Friday at 7:30. you're new, this is the tips for you. Electrostatics, capacitors, current electricity. Current and electricity available on both YouTube and Unacademy Learning App. Unacademy Learning App, maybe you want to skip one session and attend the next session. So that way you will have all the different kind of model problems has been discussed over there. Units and dimensions, I think if you attend it on Unacademy Learning App, that itself is good enough. 5 sessions altogether, everything has been covered, but a little fast it might be. If you feel it a little fast, you can come back to YouTube and start attending it, just those parts which you feel it as little fast, but I would typically recommend you to cover within those 5 sessions. And electrostatics, it's going on over here. Capacitors, you can parallelly start attending on Unacademy Learning App. Try to cover almost 5 sessions has been completed. Try to cover them as well. And yeah, projectile motion is available on YouTube as well as on Unacademy. But on Unacademy Learning App, it's a single session. On YouTube, it's split up into 2 sessions. So I have to say, complete those 2 sessions and go to the other. Yeah, Vaishnavi, happy Diwali, guys. And that being said, let's do a thing. I hope you have noted down the graph. Let's take up this problem tomorrow. This is a very interesting problem. Again, non-uniform charge distribution. It's the same kind of one. We'll do it tomorrow, don't worry. And do remember, the most competitive IIT JEE battle ever is going to be live again. So compete live, start enrolling now. It will happen on 22nd of November. You can enroll with Murli Live coupon, use a code to enroll Murli Live. And yes guys, it's going to be the most competitive IIT JEE kind of combat. There you can win amazing prizes, like awesome prizes like MacBook Air, iPhone and Amazon vouchers, guys. Everything, like the best thing that you can win would be those. But more importantly, you will be competing with students at a national level. So that is going to be a very interesting part. It's going to be the most gamified and competitive battle ever, guys. Lots of rewards and prizes to win, and you can compete live, and you have to compete live so that you can win the prizes. So compete live, and it's going to happen on 22nd of November, and enroll now with Murli Live code. And that being said, students, if you are on Plus, and if you're planning to purchase an academy subscription, enroll soon to Optics Basics to Advanced coursework, in which we are going to cover it's a comprehensive course on optics. So we are going to cover a lot of things around optics. So we will be having 60 plus sessions just on optics, guys, just on optics. So think about your preparation around optics. If you have 60 plus sessions where we are discussing 120 concepts, and we are solving anywhere around 300 plus model problems. So this is the kind of quality that you will get on optics B2A coursework. It's a comprehensive coursework, which means we will be covering both ray optics and wave optics, and you will have an awesome session on optics. So do enroll. If you're already on Plus, do not forget to do that. If you're planning to purchase Plus, this is the time. Enroll soon, guys. And it has just been launched. Try to cover the recorded videos and then come to class every day live, so that you understand a lot of things. And tomorrow's a doubt clear session. You can attend it if you want to. And that being said, students, our team, the JEE English team, where we have educators who are IITians, NIITians, and head of coaching institutes, are all on Unacademy Plus or Unacademy subscription platform. And we have started courses on electromagnetism, differential calculus, chemical kinematics, and optics B2A as well. And guys, for 2022 aspirants as well, we have launched course on graph sets relation, redox and equivalent reaction, and advanced course on mechanics. So this is by our JEE English team. And yes, do not forget to share and like this video. So Cheswara sir, in which language will you teach if we enroll? So guys, I'm currently taking it in English. Yeah, right now it's going on in English, but in future we'll be launching it in other languages. So currently it's going on in English, guys. Okay. So yes, we have courses in Hindi as well, conducted by other JEE educators. But yeah, currently my courses are in English on Plus. Optics B2A is in English. That being said, students, do not forget to share this video. Do not forget to like this video. It's a free of cost initiative by Unacademy, where you just don't get free of cost lectures but free of cost quality lectures for your JEE preparation on this YouTube channel. So do not forget to share this video, do not forget to like this video, do not forget to keep smiling, and students, ignore gossips, work hard and smart to achieve your success. You can acquire your knowledge but share your knowledge so that you can grow your knowledge. Do not forget to click on the like button, share button and subscribe button and bell notification. Yes, Vaishnavi. So guys, if you think I'm a little fast, you can maybe slow down the video using the options on YouTube. Yeah, that is something that you can do, but I believe during concepts I'm generally a little slow. So that being said, students, you know what, if you are not yet on our Telegram channel, amazing, Chesara, good to have you, and do come to classes regularly. And students, if you don't have a Telegram app yet, first of all download it from Google Play Store and App Store and click on to this link. This link is available in the description box below. This is a JEE English channel's Telegram channel where you would get exclusive and before time updates on every class that is happening on JEE English or any class our JEE English team conducts on Unacademy Learning app. So just click on to this link. This link is available in the description box. You can click on to that arrow button and you will find this link, or else just type in JEE_English and you will still be able to find it. And that being said, guys, if you haven't started with units, dimensions and measurements yet, I typically conduct A to Z units, dimensions or A to Z series on Unacademy Learning app. So it's a separate kind of session that keeps going on Unacademy Learning app, guys. So you may want to attend that as well. And in this, what you get is again, free of cost lectures. Again, these are going to be on my end. It's going to be A to Z series, like a concept revision or a total complete lecture series, but happening in fewer sessions generally than YouTube, with different kind of model problems as well. So yes, A to Z units, dimensions and measurements, again I'm telling you, it's available for free of cost on Unacademy Learning app. The complete series is available. We have covered everything in 4 back-to-back sessions plus a 5th session on model problems. So all you need to do is attend those 5 sessions and you are ready for units, dimensions and measurements lecture. Sorry, the topic. And the reason you want to attend it, it's a very easy topic. You can easily score in your exam. It will take even less time in your exam, and it will take even less time during your preparation. Think about it, 5 sessions, it's complete. So that is the kind of thing that you want. It's available, again I'm saying you, on Unacademy Learning app. And guys, we have covered so many PYQs and model problems, and you definitely get 2 to 3 questions combined in your JEE Mains and JEE Advanced. And that being said, if you don't have an Unacademy Learning app yet, do download it from your Google Play Store and App Store. And yes, just type in Unacademy and click on to this link and click on this install button. And guys, the amazing thing is, once you start following me on Unacademy Learning app, you'll get live notifications on every special classes that are being conducted by me, so that you will get live notifications and you can attend the classes from anywhere. And moreover, tomorrow is a quiz day, so do not forget to download Unacademy Learning app and attend that quiz, guys. It's going to be a very interesting quiz. You may want to attend it, and we are going to have quiz exclusively just on electrostatic potential. Post that, we will also have class. And for Unacademy Combat as well, you need to download Unacademy Learning app. So there are many reasons, guys. So do download Unacademy Learning app. This quiz is also a free of cost feature. And tomorrow we'll be having a national level quiz. So start running it, guys, and click on this install button if you don't have an Unacademy Learning app yet. And yes, it's the most downloaded education app. And that being said, students, if you are looking for a champions tool, the best in class platform and the best in class educators for your JEE preparation, it's going to be Unacademy subscription. What do you get on Unacademy subscription? You get a structured program, guys. You get a structured program where every 4th session is going to be a doubt clearing session, and that way you will be able to maintain completeness on each topic. Dedicated doubt clearing session. Think about it. You are welcome, Cheswara. You're welcome. And yes, dedicated doubt clearing session. So think about it. After you complete each topic, you will get dedicated doubt clearing session on that topic. Yes, that is the kind of thing that you will get. And more importantly, there will be quizzes and mega quizzes that comes along with every such program, guys. Every such Unacademy Plus and subscription program, you get quizzes and mega quizzes, these doubt clearing sessions, quizzes, and this daily interactive classes are happening in a structured and a systematic manner, so that you are preparing the way you have to prepare for your JEE Mains and JEE Advanced, and you're preparing to become a champion on in your JEE Mains and JEE Advanced pursuits on Unacademy subscription. And we have the best educators across the nation on this platform, and we also have legends like DC Pandey sir on this platform, guys. So there are thousands of reasons to get onto Unacademy subscription. These are few among them. And not only that, you will get an experience of your IIT JEE exam on Unacademy subscription platform, and it is equipped with the best in class technology, and you can attend JEE preparation classes from anywhere. And guys, and we keep conducting national level test series, which is important for your JEE preparation. So click on this left hand top corner extension bar, choose plus, choose IIT JEE as your goal, and with this you're preparing for both JEE Mains and JEE Advanced, and click on this get subscription button, guys. And the beauty is, it's one subscription, unlimited access throughout the period. Yes, this is something that you want. You can enroll to as many programs as you want, and we have dedicated programs for you. And these all awesome things come at a price of 2,100, only less than 70 rupees a day. It's not even 70, but less than 70 rupees a day is what you have to pay for Unacademy subscription, guys. And you can apply Murlidharan coupon to get the best discount. Apply Murlidharan coupon to get the best discount on your subscription purchase, and to get to this price point of 70 rupees a day. And guys, if you're looking for convenient payment options for your Unacademy subscription, we have pay in parts option, using which you can split your payments into multiple parts, and you don't have to go through the hassle of paying all the fee at once. We also have access to no cost EMI, where you can split your payments into multiple parts, and you don't have to go through the hassle of paying all the fee at once. And it's a no cost EMI, so no interest would be on your EMIs on your easy monthly installments. So these are typical two ways where you can split your payments into multiple parts, and it takes away the burden of paying all the fee at once. We also give you access to other kind of traditional payment modes like debit card, credit card, UPI, etc. And guys, that being said, we also have a 12-month program, which is typically meant for droppers, long-term, and students in 12th class aspiring to prepare only for 1 year. And guys, this comes at a cost of less than 2,900 per month. And what do you get in this? We have programs plus subscription programs, dedicated for droppers batch, etc. And not only that, guys, we have 7,000 plus materials for your JEE preparation, 1,000 plus live programs going on right now. So this is the kind of thing that you get on JEE subscription platform. And dedicated programs, not only that, exclusive programs on optics, etc. is what you can see in multiple languages. So this is the place where you can get the best experience, the best learning from the best educators. So you don't have to have a second thought about it. And guys, do not forget to apply Murlidharan coupon to get the best discount, and to get the best discount and to get to this price point. So don't forget to apply Murlidharan coupon. And that being said, students, see you tomorrow on an academic quiz. Do not forget to attend it. See you, take care.